we are doing basic differentiation. This is such a long word. Okay, so what do we mean by basic differentiation? So you know, on the previous test, the last test, if I give you a function, say f of x is equals to 3x squared plus 5x plus 2, and I ask you to find the derivative of the function f prime of x, you'd have to go through this long process right here. You have to find the limit as h goes to 0, then of f of x plus h minus f of x divided by h. When we say a differentiation, what we say is to get to the answer, to get f of x right here, f prime of x, instead of doing all of this right here, we use a shortcut instead. So instead of doing the 4 steps, find f of x plus h, find f of x, subtract the 2 answers, divided by h, and then take the limit as h goes to 0. Instead of doing all of that right here, when we say differentiate or we say use differentiation, all we're saying is simply use a shortcut to get to the answer. So today, what we'll be looking at are the rules for the shortcut, or how to apply that shortcut to get ourselves to our answer. Questions before we continue? The main rule of differentiation that we need to learn, and maybe the most important rule of differentiation, is called the power rule. It is the rule that almost all the other rules flow from. And so you can see on the screen, right? No, you can't see my screen?
We can see it.
Oh. Because I'm trying out new technology, as they say. And so if I have, say, for example, f of x is equals to 6x to the 4th power, and I want to find the derivative of this function, f prime of x. To find the derivative is a 2-step process. Anybody remember what this number is called in mathematics? That number out front right here. Anybody remembers what that number is called?
Coefficient.
It is called the coefficient. And what you do is you multiply the coefficient by the power, hence the name the power rule, to get the new coefficient. So it's, what is 6 multiplied by 4 giving?
24.
And so the new coefficient is 24. And then to find the new power, we simply subtract 1 from the power. So what is x minus 1? Or what's 4 minus 1? 3. And this would be the derivative of the function. If I follow through the whole process of finding f of x plus h, then finding f of x, then subtracting them, and then dividing them by h, and then take the limit as h goes to 0. If I do all of that, this is the results that I will get.
Is that a 1 right after the f?
Right. F prime right here.
Okay, okay.
F prime is a slash.
Is it possible for you to scroll up just a little bit for a quick second? Okay, I'll take a peek.
Right, and so for our differentiation, the first rule, the first excuse me, the first thing, differentiation part A, is you multiply the coefficient by the power. This will result in the new coefficient. And then the next step is to simply subtract 1 from the power right here. Step B, subtract 1. We often say we lower the power by 1. or the power gets reduced by 1. Questions there? Comments? Queries? Concerns? So power rule, hopefully not that bad, right? All you require is 2 mathematical concepts to multiply and then to subtract 1. And at the very least, we can all subtract 1, right? Right? So if I tell you f of x is equals to 10x to the 4th power, what would be the derivative of this function right here? Somebody say that loud.
$40x to the 3rd power.
Oh, you're saying the right thing. I'm writing the wrong thing. 40x to the 3rd power, and that would be my derivative right here. Questions there?
What does it say after limit? The limit.
Limit h goes to 0 down here. F of x plus h.
Okay.
That's the derivative formula. But again, we're not going to be using that formula again until the final exam. From here on out, you're expected to use the shortcut. The next rule is your addition and subtraction rule. And that rule simply states that if I have a function where all the pieces are being added or subtracted together, and I want to find the derivative of the entire function, I simply need to find the derivative of each piece. So this piece right here, 5 times 6 is 30, x to the 4th power. Negative 3 times 4 is negative 12, x to the 3rd power. I'm reducing the power by 1. 8 3 is 24, plus 24x squared. Questions there? Comments? Queries?
All right.
You said and then you said you're all right. So which one is it? Is it the or is it the all right?
Your arrow was in the way of the 3, and I couldn't tell what number that was. So now I got it.
Oh, you can see this little my little pointing mouse right here. It's under rule right now. You can see that?
Yes, sir.
Oh wow. Oh, can you still see?
No, it's gone now.
Oh wow, that's fancy. I didn't know that. Can I select stuff? All right, I'll keep the arrow out of the way. All right, so there are 2 special rules. One for a single x. Let's say I have f of x is equals to 3x, and I want to take the derivative of this function right here. Well, this really is f of x is equals to 3x to the 1st power, correct? Well, f prime, the derivative, 1 times 3 is 3, and then that will leave me with x to the 0 power, correct? Yes or no, or maybe so.
So will we have to put 0 power, or we just put 3x?
Well, any number to the 0 power equals what?
1.
Raised to the 0 power, the power is equal to 1. This is one of the facts that you need to remember in life. So this is literally 3 multiplied by 1, which simplifies to just 3. And so the rule is, if you have a single x, you just simply drop the x to take the derivative. See how this was 3x? The derivative in one step is to simply drop the x. If I have f of x is equals to 13x, then the derivative is simply 13. If I have f of x is equals to 22x, then the derivative is
22.
derivative is 22. Likewise, there is a rule when you have a constant term. Anyone still writing?
I am. Just the bottom part.
Likewise, there is a rule for a constant. C-O-N-S-T-A-N-T. If I have f of x is equals to 5 and I take the derivative f prime of x, the answer will be 0. The derivative of a constant is always 0. Let me show you why. F of x equals 5 actually means this. F of x is equals to 5x to the 0 power. Yes? Just like we saw in the previous example, because x to the 0 power is 1, yes? Now if I take the derivative of this, f prime, 5 times 0 is 0, x to the negative 1 power. Yes or no? Maybe so. And anything raised to the 0 power is, anything multiplied by 0 is?
0.
Is 0. So the derivative of a constant, a number without an x, a number that has no variable in it, or term rather, has no variable in it, its derivative will always be 0. Questions there?
Excuse me. Where did you get in the second f of x, where it says f of x 5x? What's that thing next to it? Is that like a 0 or?
Yeah, that's a 0. I just circled the 0. It's x to the 0 power.
Oh, all right. So x to the 0 power is just always going to be negative 1.
No, x to the 0 power is 1. But when I take the derivative, I have to do two things, right? I have to first multiply. So I got to multiply this times this. What's 5 times 0?
0.
Then I have to lower the power by 1. What's 0 minus 1?
Negative 1.
That's how I got negative 1. See here, this one is f of x, this one is f prime of x.
All right.
So yeah, I'm applying the rule, the power rule of derivatives there. Any more questions? So again, the basic rule is the power rule. To take the derivative, you multiply the power and the coefficient to get the new coefficient, and then you subtract 1. This rule holds if I have groups of numbers being added and subtracted together. It doesn't matter, I just take the derivative of each one. Okay? There's two shortcuts to this rule. If you have, say, 5x, 25x, you simply drop the x, and that's the derivative. Again, you could do it the long way, multiply and subtract, but it'll take you to the same place. So why? And then if you have a constant, the derivative of a constant is always 0. The derivative of 500 is 0. The derivative of negative 2 is 0. The derivative of negative 852,563. Again, that derivative will be 0. In your textbook, how many of you will be reading your textbooks? In your textbook, if you look up the power rule, it will be written like this for you. F of x is equals to coefficient x raised to a power. Then the derivative would be multiply the coefficient by the power. And then I have x raised to the n minus 1 power. Again, this is exactly what we have been doing up until this point, yes? Try this one for me, please. I want you to send me a private message with the answer. F of x is equals to 3x cubed minus 3x squared plus 3x plus 10. Send me the derivative of this for me, please. Type it up in that thing, x, and you reduce the power by 1, so that's a 2. Negative 3 times 2 is negative 6. And then you reduce the power by x, that is 1. For the next one, 3x, we use the shortcut. If it's a 1x, you simply drop the x. You just drop the x, and that's right here. And then the last one, 10, that is a constant. The derivative of a constant is always 0. And so plus 0 is not right. You need to simplify. 3 plus 0 is just 3. And so then the final answer is 9x squared minus 6x plus 3. Again, you don't need to put the power 1 right here. Questions there? Comments? Queries? Concerns? All right, so obviously this is kind of too easy, right? Calculus has to be a lot harder than this after all. People have been complaining about calculus for years now. And so it couldn't simply be all you have to do is multiply and subtract 1, right? There has to be a little bit more to it, right? Well, it turns out there is. And what happens is that a lot of problems, you can't use the rule straight away. You have to first adjust. You have to first make some adjustments before you can apply the power rule. Power rule. You know, power rules, everybody else rules. Let's start with this example right here. Let's say I have f of x is equals to x squared plus 2 multiplied by x plus 10 right here. Hopefully you can see that this problem can be simplified, right? Before I take my derivative and apply all my fancy power rules, there's some work that I need to do right here. Namely, this is called using the, I forget what I was looking for, the another product rule, the foiling, multiply this thing out. So before I go ahead and I take my derivative, I got to multiply this thing out. X squared times x is x cubed. X squared times 10 is 10x squared. 2 times x is plus 2x, and then 2 times 10 is plus 20. And now I have each term, and now they're being all added together. Remember, we haven't said anything about multiplying stuff together. Now I can go ahead and I can take the derivative of each term, f prime. That's going to be 3x squared. By the way, there's a hidden 1 right here. So 1 times 3 is 3, plus 20x. Again, just drop the x right here because it's a single x, and then the last term is 0. The derivative of 20 is 0. Questions there? Okay, try this one for me, please. Let's say I have y is equal to 2x squared plus 3x minus 2. And see what the answers are. So this times this right here is 4x cubed. This times this right here is 10x squared. And then I move to the second term. This times this right here is plus 6x squared. And then this times this right here is plus 15x. And then I move to the last term. 2 times 2 is negative 4, sorry, 4x. And then negative 2 times 5 is negative 10. I then collect like terms. This and this is 16x squared. This and this is 11x minus 10. And now for yours. Now I can go ahead and take the derivative y prime of x, y prime. 4 times 3 is 12x cubed. 16 times 2 is 32x. And then across the 11x, you simply drop the x, and the derivative of negative 10 is 0. So of course, I don't need to put down the plus 0. And so that is my answer right here.
You forgot to subtract 1 from 12x cubed.
Thank you. Thank you very much. Anybody else? Cool, yo. All right, so let's make your life harder. That's all I'm gonna be doing today, is just making things harder and harder and harder. There's no It's not like I have anything else to do. All right, fractions and negative powers. What is wrong with me today in spelling? Oh, I know. Same thing that's wrong with me every day. If I have a function that is a fraction, say 1 divided by x to the 4th right here, the rule that we learned from college algebra is that you simply, when you move the x up to the numerator, the sign on the power will change. So equals 1 divided by x to the 4. If I move the x to the 4 to the numerator to join the 1, the sign of the power will change. Do you remember this from college algebra? No, no. But the point of doing this is that it is now in a format that I can apply the power rule. Remember, this whole section right here is about when I cannot apply the power rule, what must I do to get me into position to apply the power rule? So now I can then find the derivative. 1 times negative 4 is negative 4. And then I reduce the power by 1. Negative 4 minus 1 is negative 5. Right? Someone owes you $4 and they borrow another $1. They now owe you 5. But again, of course, just like always, if I start as a fraction, I should end as a fraction. And so if I bring it back down, again, the sign will change. And this would be my final answer. This would be the derivative of my function. Questions?
Where'd you get negative 5?
So see the power is negative 4. Right, so the power is negative 4. What's negative 4 minus 1?
5. Negative 5.
That's how I got the power. Today is a trying day, people. Get it? Get it? Trying day. No. No. Why?
Yeah.
X cubed minus 5 by x to the 4th power minus 4. Somebody said, try this one, please. So, again, before I take the derivative, I have to, again, adjust the problem. So 2x to the negative 3 minus 3x to the negative 4 minus 4x to the negative 5. Again, before I can take the derivative, I first have to rewrite it in a way that will allow for us to use the power rule. Then I go y prime. 2 times negative 3 is negative 6x to the negative 4th power. Make sure that power is negative 4. Guys, subtract 1. Negative 3 times 4 is positive. Positive. Negative times negative is positive. 12x to the negative 5. Again, you always subtract 1 from the power. And again, negative 4 times 5, that's plus 20x to the negative 6. Again, we do not leave negative powers, and so we return each of our x's to the denominator from whence they came, but then that would mean that my powers would be raised to the 6th power. My powers would be positive. Question there. Okay, so we did fractions and negative powers. Any questions there? Or you can see what you did wrong. Again, you will be getting a quiz on this on Tuesday. So, you know, if you don't gonna ask the question now, you ain't gonna get a chance to ask it before class starts. Get the quiz at the beginning of class. Radicals.
Can you sir, can you redo the first one, like the first with the 1 over x4? Can you like redo that one?
This one right here.
No, the one before that.
This one right here.
Yeah.
I'm singing in the rain. All right, so I'm trying to take the derivative of this function. Unfortunately, the power rule does not work when I have an x in the numerator. This is not right. 1 over 4x cubed. This is not the right answer. Okay, so I can't just take the derivative when I have an x in the denominator. Okay, so the first step that we have to do is we have to change the problem. So it's f of x is equals to an equivalent form. And that's going to be 1 multiplied by x to the negative 4th power. The rule simply says, if you transport an x to the numerator, the sign of the power will change. Let me see if I can do it this way. So if I take this x to the 4th right here, and I take it and I move it up right here to meet this 1 up here, what will happen is the power will change signs. This will become negative x to the negative 4. Okay, that's the rule that we're applying right here. See, now it looks exactly the same. And so with that, I can then apply the power rule to find the derivative. I multiply. 1 times negative 4 is negative 4. And then I subtract 1 from the power. Negative 4 minus 1 is negative 5. But again, I have to then return that x to the denominator. And so again, the power will change. Questions there?
That's all right. I got it now.
Cool. So that takes us to radicals. This is a fact about radicals that you recall, because you know you did it in college algebra. All this cool stuff you did in college algebra. Recall, if I tell you I'm taking the 4th root of a number raised to the 9th power, I can actually rewrite this right here, x raised to the 9/4 power. I remember this? Or if I have 5 times the 3rd root of x to the 5th power, no, let's not use 5, let's use a different number, x raised to the 15th power, then this is going to be 5 times x raised to the, that answer is not going to be what I want. Let's make it 17. That's going to be, that does not look like 17. What is wrong with that? And that's going to be x raised to the 17 over 3 power. Yes, you remember this back in the day? This becomes the denominator. This becomes the power, the numerator. Okay, yes, you remember this? Yo, no one's saying yes yet. Oh my goodness, that's a bad sign. 2 more examples. If I am taking the 7th root of x, then this is going to be x raised to the 1 over 7. Where did that 1 come from?
The x having like no power.
X doesn't have a power. The power is actually 1, right? We just don't write it down because, you know, we're trying to simplify all the stuff we write down. Yes, so we don't write the 1 down, but it's there. And then if I am taking the square root of x to the 5th power, this is going to be x raised to the 5/2 power. 5 divided by 2. Where did that 2 come from? It's another hidden number. Where did that 2 come from?
The 2nd root.
Yes, if you're taking a square root, it means you're taking the 2nd root. So there's a hidden 2 that's right there that we don't write down. You remember that, right? Whee, it's a magic 2 that is not there. Question there. So if you see a root without the radical number, the number is 2. Call that the square root or the 2nd root. So how does this help us, or why do we need to know this right here? Because if I want to take a derivative, I cannot take a derivative on the inside of a radical. If I have f of x is equals to 4 times the square root of x to the 9th power, the derivative is not 4 times the square root of 9x to the 8th. This is not the right answer. Okay, what I have to first do before I attempt to take the derivative is I first have to rewrite it in fractional power form. Okay? And now I can take the derivative. Let me pause right there. Any questions on what's just happened here? The radical is gone. It's now been replaced with what some.
Where'd you get 2 from?
Say again, please.
Where'd you get the 2 from?
Again, there's an imaginary 2 right here. Okay? I'm not here, okay.
I got you.
So the derivative is to first multiply these two numbers together. So that's going to mean 4 multiplied by 9 over 2. Okay? To multiply them, I'm going to make them both fractions. So I'm going to write it as 4 over 1 times 9 over 2, because 4 over 1 is the same thing as 4, correct? And then you simply multiply across. 4 times 9 is 36. 1 times 2 is 2. And 36 divided by 2 is 18. And so the number at front is 18 after I multiply these two together. Questions so far? Again, you're allowed to use a calculator. So if you have a calculator that can do fraction multiplication, go right ahead. If you're not sure if your calculator does fraction multiplication, I suggest you come to my office hours and I can show you all the fancy powers that your calculator possesses. The next step is I have to subtract 1 from the power. So 9 over 2 minus 1. 9 over 2 minus 1 over 1. Again, gotta make them both fractions before I can attempt. But again, when I'm adding or subtracting fractions, I have to make the denominators the same. And so I'm going to write this as 9 over 2 minus 2 over 2. Right? 2 over 2 is the same thing as 1, correct? But now the bases are the same. I can work this out. 9 minus 2 is 7, and you keep the denominator. And so then this is raised to the 7/2 power. Questions there? Of course, like before, if I start as a radical, I will end as a radical. And so I got to return this back to this right here. 18 square root of x raised to the 7th power. Questions there? Questions there? Comments? Queries? Concerns? Now, this is a lot of math right here. One of the nice little shortcuts that exist to get from here to there's a nice little shortcut that can take you to this answer right here. Question, what is 9 minus 2? Give us, what's 9 minus 2?
7.
That's the new power of my function right here. Whenever you're doing radicals to get the new power, you just subtract downwards. 9 minus 2 is 7. Of course, you always keep the denominator. That's a nice little trick right there. That can get you out get you out of a little bit of trouble. Just a little. Another example. Let's say I have f of x is equals to 3 times the 5th root of x raised to the 11th power, and I want to take the derivative right here. Again, this section is about adjustments. I cannot take the derivative right away. So I have to rewrite the problem as 3x raised to, somebody can tell me what the power x is going to be raised to?
11 over 5.
It's going to be 11 over 5. Right, 11 over, kind of looks like a smiley face almost. No, 11 over 5 right here. And now I can go ahead and do my derivative. 3 multiplied by 11 over 5. Make that 3 over 1. That's 33 over 5. So that's my number out front. And then x raised to, What is 11 minus 5?
Six.
Over 5. Keep denominator. That's going to be 33 over 5. The fifth root of x to the 6th power. Y'all think y'all got it?
No, can you go over that one more time?
Okay. You want to do the same example or a different example?
You can do a different one.
You want to help me do this one, or you just want to watch me do it again?
No, I want to watch you.
Oh, you sure? Help me, you learn faster. All right. So f of x is equals to 5 multiplied by the fourth root of x to the 7th power. I am trying to take the derivative. No, a derivative. But before I take the derivative, I have to rearrange the problem. 5. This is the denominator. This is the power. 5x raised to 7/4 power. Questions there? Now I multiply. 5 multiplied by 7/4. I change the 5 into a fraction. That's going to be 5/1. And then I multiply across. 5 times 7 is 35. 5 times 4 is 1 times 4 is 4. And that gives me my number out front. Question so far? All right, with that right here, I then go ahead, 7 minus 4. What's 7 take away 4? 3, and then you keep the denominator. This is the answer, but then I have to go ahead and simplify it. 35/4, the fourth root of x to the 3rd power. Make sure you don't mix those numbers up. The 4 is in the denominator of the fraction, so it's the fourth root. And the other number is the power of x. Questions there?
For the early example, can you go back and show how you got to 6?
So 11/5 minus 1, because we always have to subtract 1, correct? Well, I need a common denominator, so instead of writing 1, I can write 5/5. Right? Because 5/5 is 1, right? 11 minus 5 is 6, and you keep the denominator. What I did was I just used the shortcut because I know that this number is always going to be the same. So that's going to be 11 minus 5 is 6, and then you keep the denominator. Was that clear?
Yes.
Anybody else? You're normally the one that gives people just a little bit more headaches. Because, you know, you all have this aversion to fractions. You'll say, fractions fooey. Then you'll storm out. Even though y'all know fractions love you all and fractions just want to have a friend so that they can talk to. Try this one for me, please. F of x is equal to 2 multiplied by the 5th root of x to the 11th power. Take this derivative for me, please. All right, so f of x is equal to 2, the 5th root of x to the 11th power. So that's going to be 2x raised to the 11 over 5 power. I can now take the derivative. So now I can write f prime, because I am now going through that process of multiplying and then subtracting 1 from the power. 2 times 11 over 5 is 22 over 5. 11 minus 5 is 6 over 5. And then I can write my answer out. 22 over 5, the 5th root of x to the 6th power. Questions there? All right, let's look at another example of this one right here that's slightly different. Thank you for your answers. Earl, the denominator should have been 5. And then double check your power. Xavier, that is right. Oh, you have them mixed up, Xavier. Again, don't mix those numbers up.
Oh yeah, I just noticed after you did it that I flipped them by accident.
Don't do the and Shamaya, that is right. All right, another example that throws students off is when you have something like this. F of x is equals to 5 divided by the square root of x to the 7th power. This is what we call a combo question, because I do have a radical, so I do need to write it as x7 squared, yes? X raised to 7 over 2. But that x is also in the denominator. And so I have to bring that x up and make it negative 7 over 2 power. Sheesh, man. Right. So this question had both a fraction and a radical in it. But now I have this right here. I can then work to my derivative. 5 times negative 7 over 2 is negative 35 over 2. Negative 7 over 2 is going to give us negative 9 over 2 when I subtract. Negative 7 minus 2 is negative 9 over 2. And just like before, I now need to unwind the equation. Negative 35 over 2, x raised to the positive 9 over 2. When I move the x to the denominator, the 2 is already there, so it meets up with the 2, but then the power on the x changes. And then after that, I rewrite it as a radical, negative 35 over 2, the square root of x to the 9th power. And that, my friend, is what they call a derivative. Oh, is it too early in the morning? A derivative.
Can you scroll back up a little bit?
I got the whole thing on there. I got one more strange example for you.
All right, thank you.
I got one more strange example for you guys. Yeah, this is just weird. Again, involving fractions. Let's say I have f of x is equals to 3x to the 5th minus 2x cubed plus 5x minus 3. And I'm dividing this by x cubed, and I want to take the derivative. Again, I have a fraction. I have an x in the denominator, right? If I go back, if you remember, if you have an x in the denominator and you move it up, what it does is that it multiplies with what's in the numerator. Multiplied by x cubed. Oh, but the power changes. You move it up, the power has to change. Yes, just like before, you bring it up, the power changes, but now it's multiplying by the numerator. Okay? And the weird part is that I have to then distribute this times this is going to be 3x squared. This times this is simply going to be negative 2 because the x cubed and x to the negative 3 cancel out. This times this is going to be 5x to the negative 2. And then this times this is negative 3x to the negative 2. Questions there? Now I can apply my derivative properties. 3 times 2 is 6. The derivative of a constant is 0, so this will go away. 5 times negative 2 is negative 10x to the negative 3. And negative 3 times negative 3 is 9x to the negative